All right, the first question that was missed by almost every class, or one of the most missed questions from every class, was this one. And basically it's understanding what they mean when they say, take the shape of the container right here. D is like a sucker question or a sucker answer, and it does not, that's not going to be it. The liquid has stronger forces of attraction between them, okay, and under the same pressure and temperature, a liquid differs from a gas because of that. Okay, the liquid has stronger forces of attraction, and so it's kind of like ball bearings rolling over each other, okay? With a gas, they rarely, if ever, touch, okay? So that's part of the kinetic molecular theory, and that's part of the change of state idea, okay? So this is something that's pretty important. Let's go on to number 5. That was another most missed question for every class, and that's which element is capable of forming stable extended chains of atoms through single, double, or triple bonds. It's got to be able to form all three, not just single bonds. And so if we look at carbon, it's kind of a unique element, and because of that, it winds up getting used throughout your body, literally. Okay, fats are carbon compounds. Okay, sugar in the blood sugar is a carbon-based compound, carbon, hydrogen, oxygen. But carbon always has to have 4 bonds. And the one that you've seen most commonly has been the methane molecule. But let's look at 2 carbon compounds that will have 1, 2, and 3 bonds. And we're going to see this in organic chemistry a little bit next week. Hopefully by the end of this week, a little bit of this. But this is organic chemistry. It deals with hydrogen-carbon compounds. Oops, let's see. This is going to be an H. Okay, this guy we call ethane. Ethane, single-bonded carbons. Okay? If we talk about octane, that would just have 6 carbons in the chain. Or 8, I'm sorry. Octane would have 8. Okay? Sextane, hexane would have 6. Septane would have 7. And they're just long chain carbon compounds. And if we're talking about gasoline, the most common one in gasoline is an 8-carbon compound. We call that octane, and you see on all the gas pumps. Next time you go to a gas station, look at the gas pumps carefully. You'll see it has an octane rating on the gasoline, because octane is a major component and one of the hottest burning of the carbon compounds, and not the hottest burning, but one of the hotter burning compounds. And you've got to be careful not to get stuff that has too much energy, because that'll burn out your motor. And that happens in racing cars when they put NOx in to get a real boost out of the car. It toasts the engine. They usually have to replace an engine that's been using NOx in a race. Yeah, nitrogen monoxide. Or nitrogen dioxide, I'm sorry. NO2. Okay, now, so ethane is one of these guys, has a double bond, and this guy has more energy when it's burned than this one does because of the double bonds. Double bonds are harder to break, and when they break, they release a lot of energy. Okay, so this guy is a two bonds in between the carbons. And then there's the third one, and this guy is the most energy, and they use this in acetylene torches. It's called, common name is acetylene, but it's also called ethine, E-T-H-Y-N-E. The Y-N-E indicates that you have 3 bonds between carbons. Okay? And if I put a long chain of carbons out here and a long chain of carbons out here, it would still be called a Y-N-E molecule, and then we'd have to state in the name where in the molecule that triple bond is, because it makes a difference as to how it reacts. So here we see single, double, and and triple bonded carbons. And that's what they're looking here. See, single, double, triple. That was the whole deal. All right. So going on, let's look at the next one down was 9, or I'm sorry, 8. 8. When someone standing at one end of a large room opens a bottle of vinegar. Okay, this whole thing is boiling down to random collisions. Right here, letter A. Random collisions between the air and the vinegar molecules. Okay? And essentially in gas, there's no attractive forces. Go figure. Why? Because they're so doggone far apart. And the chemical reaction with Nerv's idea, nah. Letter D, increases in the airspace occupied by the vinegar molecules. Way out. That's really a bad answer. So right there, your random collisions. So if you drop a bottle of perfume in the front of the room, the people in the front row are going to get it first. It smells. Let me out of here, right? Especially if it's very strong perfume. You know, the kind that you can only put on one drop. If you put any more than one drop, you'll stink everybody out that comes close to you. Depends. I have something called glacial acetic acid, which is something like 19 molar acetic acid. That stuff, you open that up, that'll drive you out. Oh, it's bad. It's worse than perfume. Yeah. But, you know, normal vinegar, some people can't stand the smell of vinegar. You know, I happen to like vinegar and oil dressings on my salads. So, yeah, good stuff. Anyway, that's what this one is all about. And going on to number 9, methane. Okay, look at this. KMT again, kinetic molecular theory. What I tell you, lots of questions on kinetic molecular theory. You're going to see them. I know you're going to see them. They wouldn't have that many in the release questions if you didn't expect to see that on the actual test. So diffuses through the air because it is, Spanish says, dissolving quickly, traveling slowly. No, moving randomly. The moving randomly, letter D. Okay, kinetic molecular theory. That's what it's all about. Stuff moves out. It's going any old direction. So not everything is heading toward the back of the room. We open the jet here. Here. Okay. You guys up front are just beginning to smell it, right? Can you smell it in the second row? No. I just opened the gas jet, and front row is already smelling it. I know I'm smelling it. Why not? That's not the methane that I'm smelling. It's the scent that they put in the gas. Okay, but it moves through the room. Anyone in the second row smell it yet? No? Okay. Did you get some? You must have gotten something. Yeah. Yeah. The smell of gas. Okay, if I continue to leave that on, the neat thing is that you will smell it before it gets to a dangerous level and, you know, literally blow the room up. If I open up the gas jets and let them go for, I don't know, 20, 30 minutes, and little match, it's over. This room is kaboom. Yeah. So, oh yeah, that would be awesome. Oh yeah, fun. Okay, one more thing. P1, V1, over, N1, T1, equal, P2, V2, over, N2, T2, P1, V1, over, N1, T1, equal, P2, V2, over, N2, T2! What? Oh, did I forget one? Oh, no! That's terrible. Okay, now let's look at this. We got 400 mils. Okay, what is that? Volume or pressure? Volume. Okay, there's our V1 of chlorine gas at 400 millimeters of mercury. What's that? P1. Decreases to, okay, we're getting the second condition now. And what is our 200 mils? V2. So we're looking for our second pressure, right? And is the N or moles mentioned? Is temperature mentioned? No temperature is mentioned. Constant temperature. That means it's not changing. So if it doesn't change, it cancels out. Good question. Yes. The temperature is mentioned, and this is T2. But at any rate, when the temperature is mentioned, in this particular case, it's mentioned as just a constant that isn't going to change. And so that's how you can do any of your gas law problems. What you're going to see on the CST is P1 V1 over T1. They will give you that formula. It'll be on a sheet that comes in your CST test. If you just add the N1 down there on the bottom, you'll be able to do any gas law problem that involves temperature, pressure, volume, and moles. Any of those that change, you'll be able to do those problems with this. And that concludes this particular review of the